Hello everyone, welcome to the YouTube channel Mission Net Physics Exam. And guys, today we are gonna discuss something very important for your upcoming GATE Physics exam. But even if you are preparing for the CSI or Net Physics exam, this video will be helpful for you as well. And guys, this video is gonna be in the Boom series for the GATE Physics exam. And all the related videos which I will upload in this series will be equally important for the CSI or Net Physics exam and all other similar exams. So you can watch these videos even if you are preparing for any other exam. So I will soon start the discussion about all these important concepts and the points I'm going to discuss in this video today, and keep on watching it till the end so that you will not miss any important concept, point or the formula. Even in between, I will keep on providing you the tricks related to a particular concept wherever it will be possible. Along with that, guys, if you are new on this channel, that is Mission Net Physics Exam, then you can subscribe the channel by clicking on the subscribe button below this video. Also click on the bell icon so that you will not miss any important video which I will upload on this channel, that is Mission Net Physics Exam. Now let's quickly talk about this Boom series and how we are gonna do the discussion in this series and actually what I'm gonna discuss today. So basically here in this video I am going to discuss most of the concepts of mathematical physics which are like related to the questions which were there in the previous years since 2010 till 2020. That means last 10-year question papers. Based on these question papers, I'm going to tell you the most important concepts based on which even you can expect the questions in your upcoming exams. And if you are someone who is not confident about the preparation till now, as you are just having few days remaining before your exam, I hope these sessions, these videos will be helpful for all of you. After watching it, please let me know in the comments how did you find this video, and let me know exactly whether it's gonna be helpful or not. Like whatever you are gonna feel about the video, about this type of discussion, you can tell me about it. Clear? So let's start the discussion now, and there are many important concepts. Basically I have noted down 25 points till now, but in between I will keep on including more and more concepts and will keep on telling you wherever some addition will be required. Okay, so I will keep on providing you more information too. So the first point, as this discussion or these points are mainly based on the type of questions which we are having in the last 10 years. Clear? So let's start with the first one. So the first point is the number of independent components if you want to find for any anti-symmetric tensor. Okay, then how many independent components will be there? So if they have given like I is equal to 1 to 5, or I and j values have been given to you, so that maximum one you will consider it as 5 here. Done. So the formula for the number of independent components for the anti-symmetric tensor will be equal to 1 upon 2 n into n minus 1. Even for the symmetric matrix, I have noted down, symmetric tensor, I have noted down the point, like in the following points you are going to have that point too. So there just one change will be there in this formula, the sign, and you will get it okay in the following points. Now the second point is, if you are going to have a question based on contour integration, and in that case the steps generally we take are, we find the pole. Okay, what is this pole actually? The pole is a finite value of z at which the function's value is going to be infinity or not defined. So if you are going to find the pole and that pole is not existing within the given contour, if the contour is going to be a circle, if even it's going to be integration limits minus infinity to plus infinity it has been given to you, then in that case we generally take the real axis or upper half of the complex plane. Clear? So if the pole is not existing in any of these reasons, so then even you can consider this thing. As per this point, I'm going to tell you, if the pole is not existing within the contour, there is no such pole existing within the contour, you can directly say that the integration will be equal to what? 0. Okay, it's so easy and simple, like you can directly write it. You don't need to spend more time, just check the pole first. If the pole will be existing within the contour, you will go for the residue part and you will just write the final answer as per this formula, that is 2 pi iota into sum of residue. Even you need to check the direction of the contour. I will tell you about that point too, okay? Clockwise or anti-clockwise, how it's going to affect the answer, or what are the sign changes like you will have to consider. We'll talk about it. Now next point, eigenvalues of any square matrix if you want to find. In the previous years we are having so many questions based on this point. So what you exactly need to do, you need to use the formula that is determinant of m minus lambda I is equal to what? 0. Clear? So where m is a square matrix, I is the identity matrix, and lambda symbol we have taken for the eigenvalues. Now in this case, if any matrix is 2 by 2 order matrix, generally you will have the 2 eigenvalues existing corresponding to that. Now eigenvalues can be degenerate or non-degenerate eigenvalues. What I mean by degenerate eigenvalues, if you are just getting 2, okay, or let's say 2 comma 2. So 2 is what? For 2 by 2 order matrix, if you are just getting 2 comma 2, same eigenvalues, so that is degenerate. If you are getting for 2 by 2 order square matrix, let's say the eigenvalues you are getting 1 comma 2. So these are non-degenerate, which means they are not generating again and again, they are different, okay? And total number of eigenvalues for any square matrix will be equal to the order. And order means either number of rows or number of columns. I'm not considering the multiplication of both, okay? Next, if we are going to talk about the Laplace transform of any matrix, so in that case guys, you are going to have the formula that is Laplace transform of any function fx. It will be equal to integration 0 to infinity e to the power minus sx fx and dx. Okay, that's how you can find the Laplace transform for any given function. Even if you want to check out the details about any topic, the other formulae, the more details about it, I have already uploaded the separate videos regarding many topics which I'm going to consider here, okay, like differential equation, the steps to just solve different type of differential equations, contour integration, Laplace transform, matrix. You will get the separate videos based on these topics too on this channel, that is Mission at Physics Exam. You can check them out too if you want to know about the details, okay? And you will be able to get to know about everything you need to know basically to solve any question related to the topic. Now next point, so here we have just considered if there is any function fx and you want to find its Laplace transform, then what you have to do, you will just have to use this formula and that's it, you will be able to get the answer. Now the fifth point is, if there is any non-homogeneous second order differential equation and you want to find its solution, so what you will have to do, non-homogeneous means what? Non-homogeneous means second order differential equation and the right hand side is non-zero, okay? Non-zero means it can have exponential function in it, it can have polynomial, it can have a constant term, okay, or anything like that. So how you will proceed further? I have taken one example by taking the exponential in the right hand side. As I have told you, if you want to go through the details about any particular topic, you want to know about it, you can check out the videos I have uploaded separately for the different topics, okay, on the channel, that is Mission at Physics Exam. So you can check it out and you will be able to know about the all steps and all the different conditions and everything. Clear? Now, so the solution for the non-homogeneous second order differential equation will be in two parts. The first one is complementary function and the second one is the particular integral. So you will have to find both and the sum of both will give you the final answer. Clear? But the point is how to find the complementary function. So here I will just provide you a general idea about it. The complementary function is basically, for that you will have to firstly write the auxiliary equation, okay? Now what is this auxiliary equation? To write the auxiliary equation, you will have to consider the d by dx is equal to small m, okay? And then you will write just the left hand side part, whatever is in the right hand side, the extra term, the constant, exponential, trigonometric function, any other thing. Just don't consider that when you are considering the complementary function part or you are writing the auxiliary equation. Next point you will have to do that, equate it with 0 simply. As I am saying, don't consider the right hand side part which is exponential or anything like that. Done. And then depending on what are the values of m you are getting, are these real values, real and equal, real and unequal, complex numbers, complex conjugates, like whatever values of m you are gonna get, depending on that you will write the final complementary function. Now how to select the final complementary function? For that, if you want and if you are not familiar with it, because there will be like many points, so if I'm going to include everything here, like all the details, it may be a very lengthy video. So that's why I'm providing you the information here. But again, to get more details about any particular topic, you can check out the separate video too. Clear? If you want. Now next point is, and that even you will get here only on this channel, so I have already uploaded all those videos. To get the particular integral, what you need to do, you basically need to write this type of expression. What is this? This is 1 upon fd e to the power ax. What is this here? What is this fd representing? So basically fd is what? When you will have d2y by dx square plus 4dy by dx in this form, you will have the equation given to you, the differential equation. In that equation, if d by dx, you will put it as like capital D. Okay, so and you will take y common, so the remaining function in the left hand side part will be representing the function of d. Like we were putting m here, instead of doing that, here we are considering d at that place. Okay, that's it. So that will be fd. The right hand side part is exponential, for example. Then you will just write it here, and now next step will be for exponential. Especially these are the steps you will have to take. For any other case, there can be different steps. Okay, so now next thing is, when you are gonna have exponential e to the power ax, where a can be any constant, 2, -1, 3, 5, anything like that, you will just have to put it here at place of d in this equation, and you will get your final answer. That will be 1 upon fa e to the power ax. Clear? Next point. If by chance fa will be becoming equal to 0, then in that case what will happen? Then in that case you will have to write x here, okay, and then differentiate the fd part. Basically this one you will have to differentiate it with respect to d, okay, and you write it here. Then you will have to put d is equal to a in the differentiated expression, and then this will be your final answer. And again, if by chance this value is becoming equal to 0, you will have to use another formula. What will be that formula? That will be x square 1 upon f double dash a e to the power ax. That's how, like, the second order derivative you will write, and here you will write one more x, or you can say x square, and that's how you will be able to get your final answer. Okay, so f double dash here you will have to take in the next step if still it's becoming equal to 0. Next one. So 6th point, if we are gonna talk about that, like it was a question in the previous years, and you may even expect some of the questions in upcoming exam. As we all know, for the GATE exam it is very important to solve the previous year questions. Okay, so that's what we are doing here, that I'm trying to let you know everything about those 10 years, like the type of questions which were there, the concepts which you can include, the way you will write the answer, okay, the most important expression and the formulae. So everything you are going to get one by one. If two matrices A and B are said to be similar, okay, then in that case how you can say that they are similar? In this manner we are considering it here. That is, B and A and B matrices were there, so we have mentioned B is equal to P inverse AP. Okay, for some invertible matrix P. Now we were talking about A and B to be similar, so what is this P here? So P is invertible matrix. Okay, next point. Then A and B have same eigenvectors. If any matrices we are gonna have like the A and B and the P is the invertible matrix there, then this is something which can work as a condition and can help you to answer any question directly. Okay, so you can even consider this point, it can be important for you. Next point, the curl of the gradient, okay, of any scalar, if you will find, that will be equal to what? 0. But be careful about one thing here. Like in a session I was discussing some question based on this formula. So what was happening, somebody has just considered if it was a here instead of delta, and it was like the gradient of v. Okay, so it was a here. A is a vector, it's not a curl. Okay, then in that case just be careful about the type of vectors which have been given to you. If it is not a curl and some particular vector has been written here, you will have to simplify it. It is basically for the curl part. Okay, that means if delta is present here, then you can use it. Clear? And if some other vector will be present here, then you will have to go with the detailed steps, and like you will have to check what exactly is going to be the expression. So don't use this condition anywhere randomly. If the vectors will get changed, that means delta will be replaced with some particular vector. You will have to check it with the complete process. Okay, so be careful about that point too. Next one, point, that is 8th point. If we are going to consider the matrix, okay, and its eigenvalues are there, then sum of eigenvalues will be equal to what? The trace of the matrix. Okay, that is square matrix whose eigenvalues we were considering here. Okay, next one, the product of eigenvalues will be equal to what? The determinant of the matrix. These 2 points related to the matrix topic are very important, and you can expect some question based on these points. And if you are someone like who was not familiar with the points earlier and getting to know about it just now, it's okay, you got to know about that before the exam, and it will be helpful for you. If you want, you can check out some previous year questions, and I hope once you're gonna watch this video, you will be ready to solve any such previous year question based on these concepts. Okay, and you should be confident about that too. Next one, the unit normal vector to the surface, like let's say any surface has been given to you in the form or as an expression in terms of x, y and z. So I have represented it here phi x, y, z. Then how you will be able to get the unit normal vector corresponding to that given surface? So what you will have to do in that case, you will just have to simplify this expression. What is that? Delta phi, which means gradient of phi upon the magnitude of delta phi. We know we find the gradient for any scalar. So that phi x, y, z which I am talking about will be any equation in terms of x, y, z. For example, x plus 2y plus 3z equal to 5. So you can take that 5 in the left hand side too, and then make it equal to 0, and this expression, okay, which is x plus 2y plus 5z minus 5, you can take it as pi xyz, or it can be x square plus 2y square plus 3z, like that. Done. So you will have a scalar. That means I cap, j cap, k cap are not there, vectors are not there, the unit vectors are not there, and we find the gradient of a scalar. So that's what we are doing here. For any given surface equation, we will just use this expression and we can get the answer easily. The denominator part will be the magnitude of that particular vector. Clear? That's how you need to consider it. If they have given that find the unit normal vector to at some particular point, the coordinates of the points will be given to you 1 1 1 1 2 1, like that. So you will just replace x, y, z at the end with that particular coordinate, okay, for corresponding to x, y and z, and you will get your final answer. Next point, if we want to find the like some vector based questions, generally they have been asked in the GATE as well as in the CSI or net physics exam. So if you're gonna have the surface integral given to you, and sometimes such type of questions are gonna be quite easy if we are gonna just convert them as a divergence part or the curl part. So there in those type of questions, be careful about it, because most of the times we require or we need to replace the surface integral with the volume or the line integral with the surface integral, like this, by changing the expressions as per divergence and the Stokes theorem. So if you're gonna have any vector present here in the along with the surface integral, then you can even write it as the volume integral of delta dot f, that is the divergence of that vector, and dv. Clear? That is the volume element you will have there. Okay, next one. If we are going to talk about the line integral, so in that case you can convert it into the surface integral by taking the curl, okay, of that particular vector. So these theorems are very important, and please make a note of these theorems. If you are not having a good command on them, they will be helpful for you. Clear? Next one. So you can prepare them, still you are having some time, okay. Next point, the matrix if we are gonna consider that we are gonna have the vectors given to us, okay, and we want to know whether these vectors are linearly dependent or independent. Clear? And let's say three different vectors have been given to you along with I cap, j cap, k cap, or something, even two unit vectors in some of the equation you can have, and you want to know whether these vectors are linearly dependent or linearly independent. So what you can do, you can write those vectors like their coefficients of I cap, j cap, k cap in the columns of any matrix. Okay, so you will consider them in the column, and then you will make a 3 by 3 matrix, particularly if you are going to have the vectors in like in terms of, or you can say corresponding to I cap, j cap, k cap given to you. So write a matrix, find its determinant. If determinant is equal to 0, the vectors are linearly dependent. If the determinant is non-zero, the vectors are linearly independent. That's so easy to check, okay, and that's what I have mentioned here. Even if there are some vectors given to you, sometimes in some of the questions they have mentioned the point related to orthogonality, okay, of vectors. So when we can say that two vectors are orthogonal, when they are perpendicular, and we know as per the dot product of two vectors, vector A dot vector B will be equal to AB cos theta. When theta will be 90 degrees, we will say, okay, the dot product is gonna be equal to 0. Why? Because the cos 90 is equal to 0. Clear? At the same time, if you want to know about two vectors U and V, whether they are orthogonal to each other or not, same thing will be applied here. If their dot product will be equal to 0, you can say the vectors are orthogonal to each other or perpendicular to each other. Next point. If we are going to consider the number of independent components for any symmetric tensor, okay, symmetric tensor given to you. So I have shown that tensor in this way, that is A11 is the first element, then A12, the first row, first column, first row, second column, first row, third column, like that I have just shown it here. In that case, we know that if it is a symmetric matrix, A21, A12 both will be equal, A31, A13 both will be equal, but and A32, A23 both will be equal because it is a symmetric matrix. So that is the condition of symmetric matrix, that the transpose and the matrix itself both will be equal. I will even show you those conditions in the following points. So in that case, these three equal, but these three can be different too. Clear? So 3 and 3 total, like you will have how many independent components? 6. The formula to find the number of independent components for the symmetric tensor will be n upon 2 n plus 1. The first point we have discussed was about the anti-symmetric tensor. There we had just a negative sign here. So you can see the difference, and as they have been asked earlier, this time even you can have some related question. Clear? Let's talk about the next point. If we are gonna talk about the next point, it's actually the 13th point is not visible here right now. There was some expression, I think it was A cross B cross R, okay, some point like that, okay, then there was a particular value of that particular point that was equal to 0, but it's not here, so we will not consider it right now exactly what was the expression. And that was one of the points from the questions, that is previous year questions. So let's just keep it as it is. If we will have that later on, we will check by considering that if we can get that expression exactly, and it is one of the previous year questions expression. Okay, next point, residue. If you want to find for any nth order pole, okay, so in that case where n is greater than 1, what is the formula? Because in the previous years you are having particularly one question in which they have just asked you to find the residue for any nth order pole where n is greater than 1. So they just asked about residue. So the formula is here, which is 1 upon factorial n minus 1. There is nothing, like I have just considered residue of, but it got removed on its own, so let's remove it completely. Let's write it here. Clear? Now if we are going to consider the residue for that nth order pole, okay, So in that case, what will happen? It's gonna be 1 upon factorial n minus 1, dn minus 1 upon dz n minus 1, z minus a to the power n, fz is that function for which that pole is existing, and its value at the end after doing the differentiation and after simplifying the curly bracket term, you will just directly have to put z is equal to a at places of z, okay, where z is equal to a is the pole corresponding to that given function fz. Next point, unitary matrix. What is this unitary matrix, guys? The condition I have mentioned here because it is important for everyone to know about it. And what is that condition? It is A dagger A is equal to I, identity matrix. Orthogonal matrix, A transpose is equal to I, that is again identity matrix. Symmetric matrix, if A is equal to A transpose. Skew symmetric matrix condition, if A is equal to minus A transpose, you are gonna get that represents the skew symmetric matrix. Next point, if you are gonna have any question in which you are considering that okay, this pole which I am able to see in the given expression, it looks like it is gonna be a simple pole, okay? So if you are considering it, or if you are thinking yeah, it can be a simple pole and there is great possibility regarding that, but you are not 100% sure, or in the options you are even having some other option which you are thinking yeah, it can even be correct. So whenever there is gonna be any situation of any kind of confusion in considering whether the simple pole part or whether this point is the right answer or not, what you can do to get sure whether it is simple pole or not, you will find the residue for that given function by considering that particular pole as simple pole. And if that residue, okay, you will use the formula which is particularly for simple pole, okay? And if you are getting the residue not defined or infinite, in that case you will say okay, your assumption or what you were considering that it is a simple pole, it's not correct. That means it will be some other order pole. Then go for some other option and check it out whether it is simple pole or not, or just by looking the expression you can get some more better answer. So this is a way of checking whether any pole existing for any given function can be a simple pole or not, or whether it is actually a simple pole or not. Clear? Because such type of questions we are already having in the previous years many times. So this is going to be one of the important points to include here. Now, next point, that's going to be related to Dirac delta function. If you are going to have any question related to integration a to b fx delta x minus t dx, where delta symbol is for the Dirac delta function we have mentioned here. A and b, I have taken some finite limits. Instead of taking minus infinity to plus infinity here, I have particularly mentioned a and b. Fx can be some function of x. In place of fx you can even have fy, fu, anything like that written, okay? So in that case what you will do, the first step you will do is you will take here is that equate this Dirac delta function bracket part with 0, and be careful about one point. What is that? The coefficient of x here must be 1. If it is not 1, if it is something else 2, 3, 4 like that, you will firstly have to take it common, and just after taking it common write 1 upon mod that part, and then write normal Dirac delta function. Whatever you will get extra term here in the denominator in the second part, you will have to consider it. That is the second formula or the another formula of Dirac delta function. So basically the coefficient must be 1 to apply this formula directly. In that case, when you are going to equate this bracket part with 0 and you are getting x is equal to t, and the t is existing within the limits a and b, okay, then your answer will be ft. Basically this function of fx is given here, you will just write x is equal to t here and you will be able to get your final answer. And this is in the case when t is existing between a and b. The another thing is, if t does not lie between a and b or not existing between a and b, then what you will have to do, you will get or you will write the final answer equal to 0, okay? So because it's not lying, the value of x which you have got is not existing within these limits, then the answer will be what? 0, okay? That is something related to Dirac delta function which is very important. Next one, related to Fourier transform, the first thing I'm going to tell you is the formula. What is that? If you want to find the Fourier transform for any given function fx, then what is the formula you are going to use? So basically we are gonna have two different formulae here. How? See, for BSc, MSc, okay, or for engineering mathematics. So the maths you are gonna consider in bachelor's or like BSc, MSc, and then in engineering part. So there is like one thing which can be different. What is that? Root 2 pi or 2 pi. Okay, root and without root. So sometimes at some of the places, in some of the books, you may even have 2 pi written there. But normally, okay, what we consider root 2 pi, okay. But if you are even gonna get 2 pi in the question, it's okay, that's right, clear. And if there is no choice related to root 2 pi part, so that's all right. But if you are gonna appear or attempt the GATE exam, I think you should go for the engineering part. That's gonna be 2 pi there, okay. So be careful about it. I'm just telling you, because if you will have only one thing written somewhere, you will not get confused and you will have an idea about it that yeah, it's a possible case. Clear? Next point, 1 upon root 2 pi integration minus infinity to plus infinity fx e to the power iota sx dx. If somebody will ask you to find the inverse Fourier transform, what you will have to do, like fx will remain there and the rest of the terms you can take this side like in simple manner, and the exponential will become with a negative power, okay. Like right now its power is positive there, so that will be a change which will take place, otherwise the things are going to remain same. Next point, the Fourier sine transform, if you want to find what it will be, it's going to be root 2 upon pi integration 0 to infinity fx, that function for which you want to find the Fourier sine transpose transform, and then it's gonna be sine sx dx, okay. Just basic formula I mentioned here, and you may need it whenever you want to find the Fourier sine transform or the cosine transform. So here you are again gonna have same thing, just cos here and the function for which you want to write the Fourier cosine transform. Done. Now change of scale property related to Fourier transform, what is that? If for example you know about the Fourier transform of any function fx, clear, and that is we are saying okay it is fs. Why we are writing it fs? Because even if you are going to consider the main formula of the Fourier transform, there was a term e to the power iota sx, and there will not be any particular value of s which you will put here, so it remains in terms of s only, okay. In that case what's going to happen, if let's say you are saying the Fourier transform of any function fx is equal to fs, then the Fourier transform of function of ax will be equal to what? 1 upon a fs upon a. Clear? 1 upon a fs upon a. Next point, the shifting property. What is that? See, in this case, what will happen if you know about the Fourier transform of any function fx and that is equal to fs, then the Fourier transform of any function, similar type of function, but there is one difference. What is that difference? Look at this. This x is this x, but here plus minus a is something additional written there. That means in this function wherever x was present earlier, now at that place either x plus a or x minus a will be present, okay. So that is a difference, and if this kind of difference is there, then what will be the changes in the answer? So earlier you were getting fs as the final answer, but now you will get e to the power minus plus iota sa fs. This fs is exactly same this one. Done. And that will be your final answer. So you can directly use this expression, and there was a question based on this property in the previous years, so you should know about it. There is again a possibility you can get the question in the upcoming exam. Next one. Oh, just a second. Okay, so next one is related to complex analytic function. Whether any function is analytic function or not, how you will get to know about it. So basically, if you are going to have any function fz which is in the form u plus iota v, you can be a function of x and y, we can be a function of x and y too. You will be the real part, we will be the imaginary part. Clear? In that case, if you want to know whether any function is analytic or not, so the first thing you can do is you can check with the Cauchy's-Riemann equation. Clear? What are these equations? Here I have mentioned them. Delta u upon delta x, if it will be equal to delta v upon delta y, and delta u upon delta y, if it will be equal to minus delta v upon delta x. These two are the Cauchy-Riemann equations, and if these conditions will get satisfied, then you will say that the given function is complex analytic function. But sometimes it may not be possible to separate out the real part and the imaginary part exactly separate. Okay, so you may not be able to write them separately, the real and the imaginary form. Then what you will have to do? Then you will have to go for a trick. Okay, what is that trick? So basically, as per the trick, you can check whether only the positive integer power of z. What is this z? Z is the complex number x plus iota y. Whether the positive integer power of z is present there or negative power is present there. So if the positive integer power of z will be present there, that is z square plus 3 whole power 5. Okay, so in that case you will say, okay, it's the analytic function. But if you will have the complex conjugate of z, if you will have the imaginary part of z, if you will have the real part of z, if you will have fractional power of z, if you will have negative power of z present there in any expression, even along with the positive integer power of z, you will say function is not analytic. But the type of expression like z plus 4 to the whole power 6, z square plus 3 whole power 5, z square plus z plus 2 whole power 13, 12, 15, anything, you will say this is analytic function because only the positive integer power of z is present there, and the extra term, that is a constant term, it's okay, it can exist. And in any other case, as I have told you, okay, complex conjugate, the real part of z, the fractional power, the negative power of z, not analytic. Okay, that is the trick you can use. Next point, 20th point now, that is the Fourier series, and one point which was like expression, we were not having that exact expression there, but we will try to just include that if possible. Next point, so Fourier series, if a function fx is defined in the interval that is minus l comma l, okay, in this interval, then the Fourier series in this case will be what? Then it's gonna be in this form which I have mentioned here, a naught upon 2 summation n is equal to 1 to infinity an cos n pi x by l plus summation n is equal to 1 to infinity bn sin n pi x by l. Okay, where a naught is equal to what? You will have to consider the formula or the expression, because see, now there is a difference. At some of the places in some of the books you may have the a naught written as 1 upon 2l. Then at those places a naught here will be only a naught, not a naught by 2. Okay, so here I have already taken 2 in the denominator, so I am just writing 1 upon l here. Don't worry about it. Clear? Now next thing, minus l to l, which are the interval given to you, the lower limit and the upper limit you are considering from there. Fx dx, fx is that function for which you want to write the Fourier series. An formula, what is this an? How you will write it? From this expression. Fourier series is basically one of the most important topics from the mathematical physics part and most expected to in the GATE exam. So an formula, see, an is present with the cos part, bn is present with the sin part. So an formula is gonna have the cos in it and the bn formula is gonna have the sin in it. Okay, so it's gonna be 1 upon l again, the half of the range, minus l to plus l. The total length in between the two limits will be 2l. So half of the 2l will be what? 1 upon just l. So that half of the range value you are writing here, half of the range value, half of the range value here. Done. 1 upon l, integration lower limit and upper limit in the same way, fx cos n pi x by l dx. Next point, n values you will put later on as it has been mentioned there, n is equal to 1, 2, 3, 4 and so on to till infinity, you can have those values. Then bn is equal to 1 upon l integration minus l to l fx sin n pi x by l dx. Okay, that's what you are gonna have. Next point, so these formula you will have to prepare if you want to solve any such related question. The 21st point is related to like the type of questions we generally find in the previous years in NET, GATE and all other exams too. Sometimes they ask about any question in which some general case is gonna be there, okay, in the question, like n number of rows, n by n order matrix, this and that, n is there. but they don't talk about the specific case, they just say n. Now sometimes students are not gonna have a clear idea how they should proceed in such type of questions, or how they can take the steps and they can get the answer in such type of questions. So I'm gonna tell you what exactly you need to do. You need to consider n is equal to 3 if you think yeah it's gonna work, and even if n is equal to 2 is giving you a very clear kind of answer, you can consider that too. But if n is equal to 2 is not giving you the surety about the answer, then you can go for n is equal to 3 part, and you can get sure what exactly will be the answer you will get and how you are going to find it. Clear? So that's how, if you will make it a specific case instead of considering it as a general case, you can be you can make that question more easy, and you can have a clear idea about the further steps after thinking about it in this manner. Okay, so you can make it more easy for yourself and to proceed further to get the final answer. So that was 21st point, which I hope will be helpful for you to solve the questions in the exam. Next one is related to eigenvalues of different type of matrices. This type of question has even been asked in the previous years. So if any matrix is a real symmetric matrix, what type of eigenvalues it will have? Always real. If any matrix is Hermitian matrix, what type of eigenvalues we will have for this type of matrix? Always real. Next one, real skew-symmetric matrix that will have the eigenvalues either 0 or purely imaginary. Next point, skew-Hermitian matrix either 0 or purely imaginary. Real orthogonal matrix, unit modulus, the type of eigenvalues it will have, unit modulus. Unitary matrix, unit modulus. Principal diagonal matrix only, its eigenvalues will be principal diagonal elements. Upper triangular or lower triangular matrix also have the eigenvalues, the principal diagonal elements. If you are considering or you are thinking, oh, it's gonna be a quick discussion so fast and I'm even not able to note it down, take your time. It's like completely, you can just watch the part of the video anytime again, or you can stop at a particular point and you can note down the point. It's completely like in your hands. Done. Next point. Next point is related to the rotational matrix. So one property related to the rotational matrix is that rotational matrix is gonna be an orthogonal matrix. So by checking the property related to orthogonal matrix, even you can get sure about it whether any given matrix is rotational matrix or not. Next point, if you are gonna have any matrix for which the eigenvalues are in the form lambda 1, lambda 2, lambda 3, and these are gonna be the eigenvalues of any, let's say 3 by 3 order square matrix M, and then in whatever way you will make the changes in the M matrix. For example, I have written the two cases here. If you are gonna make the matrix M as M square or M inverse by just multiplying M with itself M, you will get M square matrix. So what are the eigenvalues you will have for the M square matrix? In the form lambda 1 square, lambda 2 square, lambda 3 square, you can have the eigenvalues for this matrix. In the same way, for M inverse, you will have the eigenvalues lambda 1 inverse, lambda 2 inverse, and lambda 3 inverse. Okay, that's how you are gonna get the eigenvalues of the new matrices you are making from one particular matrix which you already had, but you are making some changes in them. Even in the recent years, I think in the just last exam, we are gonna have a question based on this property. So you can see, you can get any question based on any property in any exam, not only in GATE exam, but yeah, mainly for GATE exam we are considering right now, but will be equally important for other exams too. Next point. If we are going to have a contour given to us which is having the direction given as the clockwise direction, then its final integration will be minus 2 pi iota into sum of residue. So that's going to be something you need to know, and if the direction will be anti-clockwise, then plus 2 pi iota into sum of residue. So guys, these were the points which we have considered here, okay, and these were quite important points. I hope everything will be clear to all of you, and if somewhere you have missed any point, you can just check it out again and you can note it down too. Now please let me know in the comments that how did you find the video. Is it gonna be helpful? Did you find like, yeah, it will work, and will it be helpful just to prepare many concepts in very less time? Okay, and most of the things were here from the or based on the previous year questions. So I have tried to include the things related to the last 10 years questions we had from the mathematical physics part. Don't forget to let me know about it. How did you find it? Clear? Or was it helpful or not? Or this boom session or boom series for the GATE exam? Clear? Next one. There are few more points I would like to tell you. So the first thing that is related to the Unacademy Plus and Unacademy Iconic subscription. And before showing you that image, even let me just tell you one more thing. That if you want to take Unacademy Plus or Unacademy Iconic subscription, because these subscriptions will help you a lot to prepare for the upcoming GATE and CSIR NET exams. And you will be able to attend the live classes by the top educators. You will get the guidance by the top educators. So all these things together will help you a lot to prepare well for your upcoming exams. Even there is Iconic subscription in which you will get all the benefits of the Plus subscription, as I've told you just now. But along with these benefits, you will even have the personalized coach available to you who will be there for you 24/7. Anytime you can ask about your doubts. There will be many other benefits you will get. I will just show you on the slide too. And whenever you are going to take the subscription, because as it can be helpful for you guys, then you can use and apply the referral code, which is Anjali Arora, as mentioned here. No space in between, spelling should be same. That's how you need to write and apply the referral code, and you can get the 10%, or you will get the 10% discount in the total subscription amount. Now there are some updates regarding the subscription. So from 1st February there will be a price hike for the Unacademy Plus subscription amount. Okay. As well as like the new prices and the current prices, like everything has been shown here. This is for the Plus subscription. In the same way, for the Unacademy Iconic subscription, there will be a price hike, okay, from 1st February. So the duration and the new prices that has been mentioned here about this. And as I've told you about the referral code, so if you are gonna take the subscription, okay, whether the Iconic or the Plus subscription, you can use and apply the referral code, which is Anjali Arora, as mentioned here. No space in between, spelling should be same. That's how you need to write it and apply it. Now, what are the benefits you will get in the Iconic subscription? Let me just tell you about them. And then we are just gonna have this discussion for this session today. So here are the benefits. Clear? Personal coach, customized study plan, unlimited practice, structured schedule, and preparatory study material, personalized doubt clearing, booster sessions and workshops, all benefits of Plus, SOP and interview preparation. So that's how you will be able to prepare, or you will have all these benefits in the Iconic subscription. But even if somebody is going to take the Unacademy Plus subscription, they will get many benefits like the classes and the courses, the well-structured and well-planned courses by the top educators, mock test. Okay, along with that, there are doubt clearing sessions in all these courses we are going to have after some intervals, so you will be able to attend them too. So even with the guidance of top educators and all the strategy they are going to provide you, you will be able to take your preparation to the next level, and a very good level, we can say. Another thing, now soon there are going to be many new courses which are going to start on Unacademy Plus. So if you want to attend the sessions of those courses from the starting, you can take the subscription too. And wherever you are going to take the subscription, you can use and apply the referral code, which is Anjali Arora, as mentioned here. Okay. No space in between, spelling should be same. That's how you need to write it and apply it and get the 10% discount in the total subscription amount. Thank you so much everyone for joining this session and for watching it till the end. Thank you.